We continue Unit 14B with multiplying rational expressions. To multiply two fractions, always multiply the numerators and then multiply the denominators. So a factor in one fraction's numerator will cancel with a factor in the other fraction's denominator. The factors of 8 are 2 times 2 times 2, and the factors of 14 are 2 times 7. There are 3 x's in the top and 4 y's. I have combined all the numbers on the top. On the bottom, 26 is 2 times 13, and 12 is 2 times 2 times 3. There are 3 x's on the bottom and 1 y. Now remember from the previous video that when a number in the numerator is the same as a number in the denominator, they will cancel out or become 1. So those 2's will go away, these 2's will go away, these 2's will go away, these x's, this pair of x's, and this pair of x's will go away, and so will this pair of y's. Anything else that's left on top, we just multiply together. So that's 2 times 7 times 3 y's and 13 times 3, and there's no variables on the bottom left. So this will be 14 y cubed over 39. In this example, we see we must factor the numerators and the denominators before we begin. So I need to do some scratch work. The first one I'm going to look at is 2x squared minus x minus 3. I'm going to use the snowflake method to factor really quick. A is 2, so that's 2 times x and 2 times x. B is negative 1, and a times c is 2 times negative 3, which is negative 6. The two factors that multiply together to give me negative 6, but combine to give me negative 1, are negative 3 and positive 2. The 2's will reduce, so on this side I have x plus 1. So 2x squared minus x minus 3 is 2x minus 3 and x plus 1. In the denominator, I could pull out an x. When I take out an x, that leaves x plus 1. On the second fraction, I could pull out a 4x, and that will leave us with x plus 1. And the bottom fraction here is already reduced as far as it can be reduced, or already simplified. So this is just 2x minus 3. Now since there's a minus sign here separating the 2x and the 3, this is all one piece. I can't separate it, so I will put this in parentheses. Now the nice thing about multiplication is that these are really over the same line, and now I can reduce. Starting from the left, I have a 2x minus 3 on top. Now I need to look on the bottom, and there is a 2x minus 3 that I can reduce. I can only reduce if there's a number on top that's the same as a number on the bottom. Here I have an x plus 1, and there's 1 on the bottom, so I can get rid of it. Now notice there's a 4 times x, but this x is not separated by a positive or anything, so I can get rid of the x as well. What's left over is the 4 and the x plus 1. And that's the answer, 4 times x plus 1. In this example, let's start by factoring 4x squared minus 4x. We can do this by taking out the greatest common factor, 4x. That leaves x minus 1. Now let's factor the denominator, x squared plus 2x minus 3. X times x is x squared, and the two numbers that multiply together to give me negative 3, but combine to give me positive 2, are 3 and negative 1. In the second fraction, factor the numerator, we get x plus 3 times x minus 2 divided by 4x. And 4x is already completely factored as much as possible. Now let's reduce. I can reduce a 4 in the top and bottom, an x. There's a x minus 1 in the numerator and an x minus 1 in the denominator. And I can also cancel out the x plus 3's. All that's left is x minus 2. Now let's look at dividing rational expressions. Let's go back to 6th grade for a moment. Remember, when I have 2/3 divided by 4/3, we keep the first fraction, change the division symbol to multiplication, and flip the second fraction. We keep it, change it, and flip it. And then we can cross reduce. 3 goes into 3 once, 3 goes into 3 once, 2 goes into 2 once, 2 goes into 4 twice. So now I have 1 over 1 times 1 over 2. And then we multiply across. So 1 times 1 is 1, and 1 times 2 is 2. Well, I do the same thing with dividing rational expressions. In the first example, I have x squared plus 4x plus 4 divided by x plus 3 divided by x plus 2. Remember, there's an understood 1 underneath the x plus 2. Now I will follow the rules of fractions that say I keep the top number, change the division symbol to multiplication, and flip the second number. Now I need to factor. X squared plus 4x plus 4 is the same thing as x plus 2 times x plus 2. And this is over x plus 3. And at this time I want to also put parentheses around x plus 3. I cannot separate the x and the 3. I have to keep them together. Times 1 over x plus 2, and I also need to keep the x plus 2 in parentheses. Now I can eliminate what's in common in the numerator and denominator. They both have an x plus 2. And what's left is x plus 2 divided by x plus 3. And there's your answer. In our next example, I have another division symbol, so I need to rewrite the fraction. Keep the first fraction, change the division symbol to multiplication, and flip the second fraction. Now that I've done this, I need to factor all the numbers in the numerator and denominators. Starting with the numerator, the factors of 2x squared minus x minus 3 are 2x minus 3 and x plus 1. The factors of 2x squared plus 8, when we take out the greatest common factor, that's a 2. And we're left with x squared plus 4. Now I need to check and see if I can go any further with x squared plus 4, and this one is complete. Next number is 2x to the 4th minus 32. I could pull out the greatest common factor of 2, and that leaves x to the 4th minus 16. X to the 4th minus 16, however, is not complete. It's a difference of 2 squares. And I can break it down to be x squared minus 4 times x squared plus 4. Now x squared plus 4 is good, but x squared minus 4 is not complete. So this is one of those problems where we have to continue until we get it completely simplified. And this is going to be x plus 2 times x minus 2. And the bottom number can be factored as 2x minus 3 times x plus 2. Let me rewrite both of these to clean it up just a little bit. And now let's reduce. 2x minus 3 cancels with 2x minus 3. The x squared plus 4 and x squared plus 4. X plus 2 divided by x plus 2. And the 2's will cancel. And all I'm left with is x plus 1 times x minus 2, and this problem's complete. In this example, I have 3 different fractions, but only one of them I have to flip, and I always flip the fraction directly after the division symbol. So let me rewrite this problem. Let's start with the first fraction and factor the numerator and the denominator. The numerator factors to be 2x plus 3 times x plus 1. The denominator factors to be 2x plus 3 times x plus 2. In the second fraction, this is a difference of two squares, so that's x plus 2 times x minus 2. This is a sum of cubes, so we use the sum of cubes formula. X plus 1 times x squared minus x plus 1 times, in the numerator in the last fraction, it cannot be reduced, so this stays, x squared minus x plus 1. And I can pull a 2 out of the denominator, and that leaves x minus 2. And now we can reduce. I am going to put a parenthesis around the last fraction numerator because we cannot divide up the x squared minus x plus 1. That's all part of one piece. It stays together. And it can eliminate 2x plus 3, x plus 1, x plus 2, the x squared minus x plus 1, and the x squared minus x plus 1, and the x minus 2. There's only one piece left, and that is a 2 down here. So the answer is something over 2, and it has to be 1. So the answer is 1/2.